Hello everyone and welcome to this lecture. In this lecture, I'm going to walk you through how can we perform some convolutions in action. So we're going to learn how can we perform blurring and sharpening. So let's get started. So first, we're going to import matplotlib.image as mpimg. Again, we're going to import matplotlib in general as plt, numpy as mp, and opencv. Again, we have done that several times, so I'm going to go through it quickly. And then the next step is this is our image source we're going to be using. All right. The next step, we're going to read our image as we have done before. So here we read the image using image opencv as well, .imageRead. And that'll be our image, and then we're going to view our image using cv2.imageShow. Shift Enter. Let's take a look at the image. Here we go. This is pretty much the exact same image as we used before in section 4.9. All right. So let's take a look at the image shape. So if we say image.shape, Shift Enter, that will give us 426 by 640 by 3. And again, because it's a colored image, that's why we have 3 channels for the RGB. And here we wanted to convert an image from BGR color to grayscale. So we used OpenCV, cv2.cvt color. We're going to pass along our original image, and we're going to simply use the conversion from BGR to gray, and that will give us our grayscale image. So here we're going to say, okay, cv2.imageShow, that will be our title of the image, self-driving car in gray, and here we're going to pass along our grayscale image. Again, I'm going through it a little bit quickly because we have done that before. So that's our grayscale image. Okay, looks great. Let's see how can we apply a sharpening kernel. All right. So as you guys can see here, this is our sharpening kernel. So if you guys recall from the slides, we have 0, -1, 0, -1, 5, -1, 0, -1, and 0. So here I just created that kind of, like matrix, and that will be our sharpening kernel. And then to apply that to our image, we can use cv2.filter 2D. We're going to pass along our grayscale image, and here we're going to pass along our sharpening kernel. So Shift Enter, that will give us our sharpened image. So let's go ahead and actually visualize our image. So we're going to say cv2.imageShow, sharpen image, or you can call it whatever, that's the title of the image. And we're going to pass along here our sharpened image. Shift Enter. Here we go. If you guys can see here, you'll find that the image has been kind of the pixels are a little bit more sharpened in a way. So the image is a little bit sharpened. All right. Maybe it's not very clear in here, but it will be way kind of obvious when we do the blurring. All right. Okay. Looks great. What if we wanted, for example, to, let's say, try sharpening kernel. Instead of 1, let's try sharpening kernel 2. So here I just added another sharpening kernel. So maybe we can just comment this, we don't need it, and maybe activate this or enable this. So Shift Enter and Shift Enter. Here we go. So you guys can see that there are different sharpening kernels that can be used. Okay, this one seems like a little bit more powerful compared to this one. But again, you guys can try. There are tons of kernels that can be used. And let's take a look at the actual blurring of the image. So what we're going to do here, we're going to say, okay, let's create a matrix, 3 by 3 matrix, okay? And that will be, the entire matrix has just ones in it. So we're going to say numpy.ones, and that should create our kind of matrix of all ones, all right? And what we're going to do, we're going to say, okay, let's take our image, which is our grayscale image, apply our 2D filter to it, and we're going to pass along our blurring kernel. And that should give us our blurred image. And let's go ahead and actually visualize or use cv2.imageShow to actually visualize our blurred image. So Shift Enter, here we go. All right, that looks kind of strange. We weren't expecting that. We were expecting when we apply a blurring kernel that we are going to kind of see like a blurred image. However, here we saw an image that is kind of, pretty much all white, which makes complete sense. Why? Because this kernel is not normalized. So when you apply any kernel, you need to make sure that the kernel is actually normalized over in the entire kernel. So here we just added kind of, like a like convolution with all ones. So when you simply apply this, that means you are shifting all the pixels towards 255 or 200, kind of, you know, like white color. That's why the image was pretty much all of it is white. However, if we take the exact same kernel in here, which is numpy.ones, again, the exact same kernel as we have before, which is here. However, we multiply the kernel by 1/9, so that will make sure that our kernel is normalized. Then we can get an actual effect that makes sense. So that will give us our blur kernel. And then here we can apply our 2D filter. I'm going to pass along our grayscale image, and I'm going to pass along our blurring kernel here. And that should give us our blurred image. And then we can use OpenCV to actually show the actual blurred image. So Shift Enter, here we go. So if you guys can see here, obviously compared to our original image, the kernel or the image has been a little bit blurred. It's not, again, very clear, but again, the image is a little bit blurred in this case. So why don't we actually maybe like step up our game a little bit and try a more powerful kernel? So here we actually used kind of 3x3 matrix or 3x3 kernel. Let's go ahead and actually try maybe a more powerful one. So let's go ahead and try, let's say, 8x8 kernel. Okay, so Shift Enter. That will give us a matrix that's 8x8 and all of it is ones. So let's go ahead and actually normalize it. So I'm going to take it again, divided by 64, Shift Enter. That will give us our blur kernel. And let's go ahead and actually apply our kernel. And as you guys can see here, now it makes much more sense. Like actually, you can tell that the image has been blurred. Why? Because now we are using a more powerful kernel that scans over a larger values of pixels, which is 8x8. And that's why you can kind of create more powerful kernels by increasing kind of the dimensions of the kernel, so you can like hover through larger values of pixels. All right, and that's pretty much all what I have for this lecture. I hope you guys enjoyed it. Let's go ahead and actually recap what we have done so far. In this lecture, we learned how can we use OpenCV to perform some convolutions. So we can learn how can we perform some blurring and some sharpening as well. We loaded all our packages, all our libraries. We loaded our image. We show the actual dimensions of the image. We converted the image from colored to grayscale. And then we used a sharpening kernel here to actually sharpen the image. And we learned that we can actually visualize a sharpened image, which makes sense. Afterwards, we used a 3x3 blurring kernel. And we learned that if we have a kernel that's all kind of ones, that's not normalized, then that means the image will be distorted, basically. That would be kind of, damaged. It doesn't make any sense, and the image, you will find that's pretty much all of it is white. However, if you actually normalize the kernel, as you guys can see here, we divided by 1/9, that will give us an actual effect that's blurring, and we can kind of improve or kind of have more powerful kernels by increasing the kernel size, by let's say making it 8x8. And as you guys can see here, we're able to actually blur the image and get more powerful results. And that's all what I have for this lecture, and see you guys in next lecture.